Hello gentlemen, purpose of this video is to start to talk about circular trig. We'll have two videos on this and that'll be it for the week. So let's get started. When we're talking about circular trig, we want to talk about the unit circle. The unit circle is a circle that is centered at the origin and has a radius of 1. And you should know way back from chapter 1 that the equation of that circle is x squared plus y squared is equal to 1, and it looks like this. Okay? The central angle theta corresponds to a point on the unit circle. So if I go, remember that we're measuring positive angles that are going off the x-axis, that's going to be counterclockwise. Okay, so let's make sure that we understand that. If I'm going clockwise, they're going to be negative. But I can choose an angle and I can get a corresponding point on that circle. Okay, so a central angle of 0 corresponds to the point 1, 0. Well, that's right there. Okay. Are there other points that correspond to that point? Well, you should understand that there's an infinite number of angles because obviously 0 is 1, but if I started here and I went all the way around like that, where theta was equal to 2 pi, I'm right back over here. Okay. Also, if I had theta is equal to negative 2 pi, would be the same thing, except I would have went in this direction here. Still back at that same point right there on the curve. Oh, I could say 4 pi, right? And that means I'm just going to do what? I'm going to go around. There's 2 pi, there's 4 pi, and boom, there I am. I'm right back there again. Okay? So understand that there's an infinite number of points that work. Let's talk about the unit circle here. This is key. You guys need to know this. Hopefully this is not new to you. Okay? You need to understand where these angles are, and we're actually going to need to know about the sines and the cosines as we're going to see in a minute. Okay, but understand that this angle, that these different angles split this unit circle up. Again, this is a radius 1. This is a unit circle always has a radius equal to 1, and these are different angles. So if I'm right here, whoops, this is pi over 6. Okay. This angle, if I'm on this line here, I'm going around 11 pi over 6. Okay, these are all positive measured angles that are on the outside. Or, if I went that way, this would be negative pi over 6. So you need to really understand and make sure you know where these different angles are on the unit circle. And we're actually going to want to know what the x and y coordinates are for each one of these points, because they're going to tell me about the trig functions, the sines and the cosines. Okay, and let's define those now. Let xy be the point on the unit circle that corresponds to that central angle. Okay, so again, going back to that previous slide here, there's a point here. There's going to be a point xy that corresponds to this angle of pi over 6. And I'm going to have them for all of these different ones. And remember, again, x squared plus y squared is equal to 1. That's the equation of my unit circle. So if I wanted to find my trig functions, the sine function, sine of theta, sine of that central angle, is going to be equal to the y value of that point. Okay? The cosine is going to be defined as the x value on the unit circle for that given angle theta. Okay? Secant theta is defined as 1 over x, or 1 over cosine. This is also 1 over cosine of theta. This is 1 over sine of theta. Okay, and there's 6 trig functions that you need to know. Okay, we have cotangent. Cotangent is going to be x over y, or you'll see it is going to be cosine of theta over sine of theta. Again, because x is cosine and y is sine right there. And the last one that we need to know is tangent of theta, and tangent of theta is also sine of theta over cosine of theta. Okay, or y over x. All right, so you need to make sure that you understand and know those. Let's divide this. Let's divide the arc, this unit circle up into 8 equal arcs. Okay. And what we want to do is find the x and y coordinates in the first quadrant that lie on the line y equals x. And so if I look at my unit circle equation right there and make use of the fact that y is equal to x, I can do some substitution in here. I can get rid of y and I can replace it with x. So I'm going to get x squared plus x squared is equal to 2x squared. If I solve this here for x, x squared is a half, or x is equal to the square root of 2 over 2. Okay? Which also means that y is equal to the square root of 2 over 2. And basically what it's saying is this. If I break this up into 8 equal parts, and you know, here's 1, 2, 3, 4, 5, 6, 7, and 8. Each angle is 45 or pi over 4 degrees away from the previous one. So I'm going to be, if I start here 1, 0, obviously, this is going to be root 2 over 2, 0, 1, negative root 2 over, negative root 2 over 2, comma root 2 over 2. Remember that now I'm in the second quadrant and the x coordinate is negative here, etc., etc. Okay? And so what this tells me is that I can look at the sine of pi over 4. Here's my pi over 4. What is my y coordinate? My y coordinate is right there. And so the sine of pi over 4 should simply equal to root 2 over 2. I can look at the cosine of pi over 4. Again, it's right here. It's the x value. Again, it's root 2 over 2. And then finally, I can look at the tangent of pi over 4, which is y over x. Remember, tangent is y over x, and that's tangent. And I get root 2 over 2 over root 2 over 2, which is simply give me 1. Okay? Here's the entire unit circle. This is the one with 12 arcs here. Okay? Again, you can break these up. You can see I'll do the first quadrant, 2, 3, and each one has 3, so a total of 12. And again, here are the x and y coordinates on the plane, on the unit circle that corresponds to these different angles. You need to know all these, okay? So that when we look at doing things like what's the cosine of pi over 3, we know that right off the bat. Okay, cosine pi over 3, here's pi over 3. What's the x coordinate? It's 1/2. Okay? What's sine 5 pi over 6? Well, I got to go find sine pi over 6. Here it is. I'm looking at sine, so I want the y coordinate, which should be 1/2. Okay? Secant is 7 pi over 6. Okay, secant, remember, is 1 over x. This is 1 over x. So now I have to find out what the x value is, 7 pi over 6. I come to 7 pi over 6. I want the x value. It's negative root 3 over 2. Okay, now I don't want to leave it like that. I got to do some manipulation. 2 comes on top. I don't like the radical in the bottom, so I have to rationalize, multiply top and bottom by radical 3. And I get negative 2 root 3 over 3. Okay? Cosecant of negative pi over 3. Well, cosecant is, we should know, is 1 over y, going back to our definitions. Now we're going to talk about negative pi over 3. Well, here is going, now we're going to go clockwise pi over 3. And so that's going to, that's going to bring us right to this line right there. Okay? So negative pi over 3 is the same as 5 pi over 3, remember? Because they're coterminal angles. If I look at that and I'm looking at the y coordinate, hey, look, it's the exact same problem that we just did. And you'll see some relationships later on as we go through. Okay, again, so I went clockwise pi over 3, found the y coordinate, which was right there. Let's look at tangent of 2 pi over 3. Let me get rid of some of this stuff here. Okay, so now I need to find 2 pi over 3, where I am for 2 pi over 3. Again, I need to know, pen back, 2 pi over 3, so here's 1 pi over 3, here's 2 pi over 3. And remembering that tangent is y over x. So I can plug in my y and my x here. I get root 3 over 2 divided by negative 1/2. Remember, when you divide by a fraction, you multiply by the reciprocal, times times 2 over negative 1. The 2 is going to cancel, and I should get negative root 3. Okay. Do another one. Tangent of negative pi, again, it's y over x. But now I have to go clockwise. That's going to bring me right to there. I have y is 0 over negative 1, and I should get 0. Okay? Let's do some more practice. You guys need to get the hang of this. Cosine 3 pi over 2. Alright, so I got to find, again, cosine is the x-coordinate. 3 pi over 2 is down here. The x-coordinate here is equal to 0. Okay? Sine 5 pi over 4. You need to find 5 pi over 4. Here it is. Okay, I want the y-coordinate, which should be negative root 2 over 2. Secant of pi over 2. Remember that secant again. Secant is 1 over x. Pi over 2 is right here, so I get 1 over 0. Uh-oh. Can't do that. You guys should know that. So we're undefined at that point. So secant is undefined at pi over 2. Can't divide by 0. What about the tangent of 0? Tangent of 0 is y over x. Okay. And so I should just simply get 0 over 1, which is equal to 0. How about cotangent of pi over 2? Cotangent is equal to x over y. And we should get 0 over 1, which again is 0. Again, just taking this point. Here's my x and y coordinate. Tangent of pi over 2. Tangent again was equal to y over x right there. And so that should be equal to 1 over 0. Uh-oh, undefined again. Okay, so we need to understand we're actually going to have some vertical asymptotes once we start looking at those graphs. Cosecant of pi over 6. Cosecant, remember, is 1 over y. And so for pi over 6, I'm going to get 1 over a half, which should be equal to 2. Okay? Here's some practice, fellas. Look at these examples here. These should be pretty quick. Hopefully you guys know this, but I'm going to circle it, and I'm going to keep telling you. Make sure you know your unit circle. You need to get to the point where I ask you what is cosine of pi over 3, and you know it's 1/2. You don't even have to think about it. It needs to be second nature. Okay? So if you don't know it, learn it, print it out, study it, make flashcards, whatever you need to do. But it's certainly going to be helpful when you start getting into calculus and certainly the rest of this pre-calculus class. Okay, so basically the main topic of this was to introduce you to the unit circle, define the 6 trigonometric functions, and then get some practice using the unit circle. Okay, have a good day, fellas. One more video to go for the week.